limits at infinity. Example 13, given f of x equal to 1 over x squared, find limit x approaches positive infinity f of x and limit x approaches negative infinity f of x. Firstly, we're going to find limit x approaches positive infinity for the function 1 over x squared. So when we substitute x equal to infinity, we're going to end up with 1 over infinity square. So 1 over infinity square, it will be equal to 1 over infinity, because we know that infinity means a very big number. So if we square the very big number, we will get a very big number. So 1 over infinity, imagine if we have a very small number, for example 1, we divide it by a very big number. So we're going to get the value of 0.00000000001. Okay, so it's going to be very close to 0. So we could say that if we have any constant and we divide it by infinity or negative infinity, we're going to get the value of 0. So in this case, since we end up with 1 over infinity, so 1 over infinity will be equal to 0. But don't show this working during your exam, because it's not proper to substitute x equal to infinity. Next, I'm going to write it down. So limit x approaches positive infinity for the function f of x is equal to 0. And then I'm going to find the other one. Limit x approaches negative infinity also for the function f of x, which is 1 over x squared. And then I'm going to substitute x equal to negative infinity. So we know that if we square any negative number, it will become positive. So here we're going to end up with 1 over infinity, and we know that any constant divided by infinity will be equal to 0. As usual, don't write this down into your working during the examination. And then we're going to write that limit x approaches negative infinity for the function f of x is equal to 0. Example 14. Find the limits at infinity for the following. A. Limit x approaches positive infinity x squared plus 3. So here I'm going to apply the property of limit, since we have two different functions and the operation between them is plus. So we could separate the two functions, becoming like this. And then, since it's not proper to substitute x equal to infinity for the working, so I'm going to do it up here. So imagine if we substitute x equal to infinity, it would be infinity square. So infinity square is actually equal to infinity. So the answer here would be infinity. And then plus limit x approaches positive infinity for 3, it will be equal to 3. Then infinity, if you plus it with any number, it will still be infinity. So the answer here would be infinity. B. Limit x approaches negative infinity for the function 1 minus 5 over x. So I'm going to use the property of limit. We have two different functions and the operation between them is minus. I would separate the two functions, becoming like this. And then here, limit x approaches negative infinity 1 is equal to 1. And then for the other one, imagine if we substitute x equal to infinity, negative infinity, so we're going to get 5 over negative infinity. So constant, if we divide it by positive or negative infinity, it will be equal to 0. So here will be 0, and 1 minus 0 is equal to 1.
About limits at infinity for rational functions. When you substitute x approaching infinity, when you get infinity over infinity, then what you need to do is you're going to divide the numerator and denominator by the highest power of x in the denominator. Alright, so you're going to divide the highest power of x in the denominator. Alright, before we start for example 15, you're going to focus on this one, yeah? So if you have modulus of x, okay, the definition of modulus of x is surd x squared, right? Okay, so when we actually express it in x and negative x, so you're going to get x when x is greater or equal 0, and also you're going to get a negative x when x is less than 0. Okay, so for these type of questions, when we approach to positive infinity, so we're going to substitute with a positive. Alright, and when we substitute x approach negative infinity, and we're going to put negative outside of our surd. Okay, I'm going to show you the example later on. Alright, so let's focus on the first example. Okay, when we have 2x cubed plus x squared minus 3 over x cubed plus x plus 2, and it's approach positive infinity. So when we substitute infinity, we're going to get infinity over infinity. So we're going to divide both numerator and denominator with highest power of denominator. So highest power of denominator is x cubed. Alright, so divide everyone with x cubed. And also the numerator, divide with x cubed. Okay, so the next step is to simplify. And then we're going to write down the simplest form, which is 2 plus 1 over x minus 3 over x cubed over 1 plus 1 over x squared plus 2 over x cubed. And then we're going to substitute infinity into this one, and also on the denominator part. Okay, so what we've learned before is when you substitute constant over infinity, we're going to get 0. So it's 2 plus 0 minus 0 over 1 plus 0 plus 0. So your final answer is 2. Okay, let's move on to question B. This time we have x approaching negative infinity. Alright, so let's focus on the highest power of denominator, which is x squared. Okay, so since we approach to negative infinity, we're going to put negative outside of the surd. Like that. Okay? Alright, so when we divide for the denominator, when we divide with x squared, we're going to divide the numerator with only x. Okay, so when it's inside the surd, and then it's going to be x squared. So when it is outside of surd, it's going to be x. Alright, simplify. 1, 1. So write down the simplest form. Negative 1 plus 1 over x squared, and then again we're going to substitute with negative infinity, so it's going to be 1 plus, so it's going to be 1 plus 0 over negative 1 plus 0, so there's no limit anymore, right? Okay, so the final answer will be negative 1. Okay, let's move on to the part C. Okay, the highest power of denominator is x. So divide everyone with x. And then for the upper part, for the numerator, so since it's inside a surd, it's going to be x squared. And then simplify. 1, 1. Then it becomes 1 plus 4 over x squared over 1 plus 3 over x. And again, we get to substitute infinity, so it becomes third 1 plus 0 over 1 plus 0. So the final answer is 1. And then for the last one, for the last example, again, approach negative infinity. Highest power of denominator is x to the power 4. And since it's negative infinity, so we're going to put negative. But let's take a look. Third x squared will produce a positive x and negative x. But this time we have third x to the power 4. So when we split it, it's going to be third x squared, third x squared. So for negative part, it's going to be negative, negative. So we have 2 negative over here. Okay. So outside of third, so x4, it becomes x squared. Simplify. 1. Limit x approaching negative infinity. So for numerator, negative, negative, positive. So 3 plus 1 over x cubed. Substitute negative infinity, so it's become 1 minus 0 over third, 3 plus 0. So the answer is 1 over third 3, or conjugate of it, third 3 over 3. Right?
Vertical asymptotes. The line x equal to a is a vertical asymptote of the graph of the function y equal to f of x if at least one of the following statements is true. Limit x approaches a from the left equal to positive infinity, or limit x approaches a from the left equal to negative infinity, or limit x approaches a from the right equal to positive infinity, or limit x approaches a from the right equal to negative infinity. For example, if we have a function 2x over x minus 1, this is the function 2x over x minus 1, then if we draw the graph, it will look like this. This is the graph of the function 2x over x minus 1. It is actually a reciprocal function. So, if you could see from the graph, when x approaches 1 from the left, so the graph is approaching downward until the value of negative infinity. And when the graph approaches 1 from the right, it's going to be closer and closer to positive infinity. Thus, we could say that x equal to 1 is a vertical asymptote of f of x. Horizontal asymptotes. Horizontal asymptotes are the horizontal lines that the graph of the function approaches as x approaches positive or negative infinity. The horizontal line y equal to c is the horizontal asymptote of the function of y equal to f of x if limit x approaches negative infinity for the function is equal to c, or limit x approaches positive infinity to the function equal to c. For example, if we have the function 2x over x minus 1, then as x approaches positive or negative infinity, fx approaches but never quite reach the value of 2. Using limit notation, we state limit x approaches negative infinity for 2x over x minus 1 is equal to 2, and limit x approaches positive infinity to x over x minus 1 also equal to 2. Thus, y equal to 2 is the horizontal asymptote of f of x.
16. Compute the vertical and horizontal asymptote of fx equals 2x over x squared minus x minus 2. Hence, sketch the graph. Okay, so to find vertical asymptote, we're going to focus on the denominator. So we're going to take x squared minus x minus 2 equals to 0. And then we're going to factorize to get x plus 1, x minus 2 equals to 0. and we get x equals to -1 and x equals to 2. So we're going to approach x approaching -1 from the right, x approaching -1 from the left, x approaching 2 from the right, and x approaching 2 from the left. And the function is going to be the same, which is 2x over x squared minus x minus 2. When we substitute -1 from the right, what you're going to get is you're going to get constant over 0. Okay, so when you substitute -1, you're going to get constant over 0. So as you have learned from previous, so we're going to make a number line over here. So it's -1 and 2 from right and left. So when you get constant over 0, your answer will be positive infinity or negative infinity. So what you need to substitute is the right side of -1, which is -0.999, and the left side is -1.001. For 2 part is 2.001, and this one is 1.999. When you substitute -1 from the right, which is -0.999, so what you're going to get is you're going to get positive infinity. When you substitute -1 from the left, which is -1.001, so you're going to get negative infinity. When you substitute 2 from the right, which is 2.001, so what you're going to get is positive infinity. And when you substitute from 2 from the left, which is 1.999, what you're going to get is negative infinity. And then we can conclude x equals to -1 and x equals to 2 are vertical asymptotes. Okay. For horizontal asymptote, what you need to do is we're going to approach the function to positive infinity and negative infinity. When you substitute infinity for the numerator and denominator, what you're going to get is infinity over infinity. So when we get infinity over infinity, what you need to do is you're going to divide the highest power of denominator for both numerator and denominator. So highest power of denominator is x squared. Simplify. And then write down the simplest version. So it's going to be 2 over x over 1 minus 1 over x minus 2 over x squared. And when we substitute infinity, you get to get 0 over 1 minus 0 minus 0, and the answer is 0. We're going to repeat the same process with limit x approaching negative infinity. As you get infinity over infinity, also you need to divide by highest power of denominator. Simplify. Write down the simplest form. Sorry, this is not positive infinity. It's going to be negative infinity. Negative infinity. So 2 over x over 1 minus 1 over x. Minus 2 over x squared. When we substitute, you're going to get 0 over 1 minus 0 minus 0. So the answer is also 0. So we're going to conclude y equals to 0 is the horizontal asymptote. Now we're going to sketch the graph. So first what you need to have is the axis. And then we're going to draw the asymptote, which is x equals to -1, x equals to 2, and y equals to 0. You cannot touch the vertical asymptote, but you can touch the horizontal asymptote if necessary. Alright, so what you need to do is, let's take a look at the vertical asymptote. As x approaching -1 from the right, so it's going to go to positive infinity. So positive infinity means it's going to go up. Negative infinity, go down. Positive infinity, go up. Negative infinity, go down. Alright, so -1 from the right, it's going to go up. -1 from the right. Okay, so I'm going to change the color to green. Okay, -1 up. -1 from the left, it's going to go down. Two from the right, go up. So this is 2, so go up. 2 from the left, go down. Okay, all right, so we've done with the vertical asymptote. Let's take a look at the horizontal asymptote. When it approaches positive infinity, means it's going to go to the right, and negative infinity to the left. As your function approaching x approaching a positive infinity, so it's going to approach 0. So to the right, 0, y equals to 0. To the left, also to 0. So what about this part, the center part? Okay, so we have to make sure your graph is touching at the right point. So what you need to do is going to substitute over here. When x equals to 0, you're going to get fx equals to 0. So basically, your graph is going to touch 0, 0, like that. Okay, so we're going to finish up with labeling x, y, and that's it. Example 17, so we have this function. So we're going to repeat the same process again. So vertical asymptote, we're going to take a look at the denominator. So assert x squared minus 4 equals to 0. X squared minus 4 equals to 0. So it's going to be x plus 2, x minus 2 equals to 0. X equals to -2 and x equals to 2. We're going to approach from -2 from the right, -2 from the left, 2 from the right, and also 2 from the left. Okay, we're going to copy down the function. And then write down the number line. So we have here -2 from the right and left, and also 2 from the right and left. So 2 from the right is 2.001, 2 from the left is 1.999. -2 from the right is -1.999, -2 from the left is -2.001. So when you substitute x approaching -2 from the right, so you're going to get undefined, which is does not exist. Okay, negative 2 from the left is negative infinity. 2 from the right is positive infinity. And 2 from the left, you're going to get it does not exist as well. Which means there will be no graph from negative 2 from the right and 2 from the left. Okay, we can conclude that x equals to negative 2 and x equals to 2 are vertical asymptotes. Next, we're going to find the horizontal asymptote. We're going to approach to positive infinity and negative infinity. Again, we're going to get positive infinity over positive infinity. So you have to divide by highest power denominator, which is the x square. And then for the numerator, we're going to divide by x. Simplify. Write down the simplest form. And then substitute to get 1 over, so 1 minus 0, which is 1. We're going to repeat the same process with negative infinity. And please remember, when you have negative infinity, what you need to do is you're going to divide the highest power denominator and put negative outside, right? And then for the upper part is divide by x. So simplified version, 1 over negative 1 over 4 over x squared. 1 minus 4 over x squared. So when we substitute, you're going to get negative 1. And then make conclusion, y equals to 1 and y equals to negative 1 are horizontal asymptotes. Let's try to sketch our graph. First, we need the axis. Asymptote negative 2 and 2. One, negative 1. Okay, there will be no graph on the right side of negative 2 and left side of 2. So we need to focus on those the side that exist. Alright, so negative 2 from the left is negative infinity going down, and 2 from the right is going up. So negative 2 from the left is going down. Negative 2 from the left going down. Two from the right going up. As it's approaching positive infinity to the right, negative infinity to the left. So when the approach x approaching positive infinity to the right, it's going to approach, it's going to approach 1. Y equals to 1 like this. When it's going to the left, it's going to approach a negative 1. Like that. Okay?